Okay, let's go ahead and continue with our notes here. We're on page 2. Okay. Starts off here. Why does the object fall back, or why does objects fall back to Earth if it's thrown up with a positive velocity, for an example of 2.3? Shouldn't it continue in the positive direction since it's thrown with a positive velocity? So the answer is no, it's not going to continue. And you know that if you were to toss something up, obviously it's going to come back down. I understand that you know that things are going to happen, but we're here in physics and we're trying to figure out and learn the why it happens. So no, it's not, because acceleration of gravity is always pulling on it down in a negative direction. The next question here says, well, how will the speed of the ball going up compare to the speed of the ball when it is falling at any given point? So the speed is the same up and as well as it coming back down at the same points or location. Okay? Next part here says here, though, example, if the initial velocity of a ball thrown upward from the ground is 10.5 meters per second, what is the final velocity of that ball at the end of the flight? If it's going to land at the same exact spot of where it was thrown up, then the ball's velocity when it's coming down is going to be a negative 10.5. Again, making sure that all of us know that this negative is direction. That's why it's there. It's not a negative value. And because it's not a negative value, that's the reason why we can toss it in and throw it out when we need to, mathematically, because it doesn't have any numerical value. All right? So let's keep going. It says here that we just said that the downward acceleration is the same when an object is moving up and when it's moving at, or even when it is at rest or at the top of the path, and when it is moving down. The only thing that changes is the magnitude of the velocity. And next part here, the direction changes of the velocity. Direction of that object. So we went over this in class, right? And as my object's going up, it decreases its velocity. The velocity goes to 0, and then it comes back down and the velocity increases. At every given point, though, the acceleration is the same no matter what. The only thing that changes is the velocity and the direction, right? Because it's going to be going up, 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 coming down, down, down. Next part here, though, objects thrown up has a positive velocity and a negative acceleration. And so it will slow down since the acceleration is working against it. So as my objects have a positive velocity and a negative acceleration, those two vectors are going to do what? They are going to be subtracted. And as my object is thrown up higher, higher, and it gets to a higher location, it's slowing down, slowing down, slowing down, because the vectors are continually subtracting, subtracting, and subtracting until they cancel out to 0. And when it cancels out to 0, that means that it is at the top of the path, way up here. It got to the top height, the maximum height that it's going to go. The velocity is 0, right? Because those vectors cancel each other out. But the acceleration is still negative 9.81. We call this location non-zero acceleration. Objects that are falling have a negative velocity and a negative acceleration, so they're going to speed up as it falls down. Why does this happen? This happens because my velocity is a downward direction vector. My acceleration is also a vector that's in the downward direction. We're going to add those two together. That's the reason why it's going to speed up. As my object is thrown up, it has a positive velocity, but yet it's going to have a negative acceleration. What happens with vector arrows that are in opposite direction? We subtract them, and we're going to continue to subtract it as it goes up. And because of that subtraction, it's going to slow down till it gets all the way to the point that it's 0 at the top, and we call that top location, the top peak, non-zero acceleration. So it says right here, to sum it all up, velocity and acceleration in the same direction are going to speed up. Why does that happen? That's what I need us to know, is the why. Why does it happen? Because the vector arrows are in the same direction, so we're going to add them together. Velocity and vector in opposite directions are going to slow down. Why does that happen? It happens because the vector arrows are in opposite directions. We subtract them, and the number is going to get smaller, smaller, smaller. And at the top, we call that non-zero acceleration at the top. And that is the top of the path, or the top peak, where at this location, velocity is 0, and acceleration is still a negative 9.81. So non-zero acceleration, meaning acceleration is not 0. Velocity is 0, but not acceleration. Now, we did this already in class, right? So I am expecting you to repeat that on here. So I'm going to go ahead and I'm going to leave this here. Why? Because this was done in class, and there are some spots in our notes that I'm going to leave yellow and that I am expecting you to complete. Okay? Remember the other first page? We did this in class. I'm expecting you to complete that in. I'm expecting you to complete this in. You're going to lose points if you don't. The next part here, practice using what you know about falling objects. So we did this practice part here in class already, right? Just as a review or as a reminder, over here, don't forget acceleration is negative 9.81. Okay, so we talked about this question here in class. A flower pot falls. In physics, the word falls has an actual number value of negative 9.81. From a windowsill. VI, because from is my initial, is 0. It's sitting on the windowsill. It's not moving. 25 meters above the ground distance, the sidewalk. How fast, question mark, V sub F, is the flower pot moving when it strikes the ground? And remember, I did the drawing. We've got some kind of building. We've got a window with the windowsill, and on the ledge is a flower pot. Remember, in physics, if you're not sure, you go ahead and draw it out. And we need to go ahead and label this distance. is going to be 25 meters, right? And we try to go ahead and do as much labeling as we can. We know that this flower pot is going to go in the down direction. So A equals negative 9.81. We know that it's not moving right here. So the V sub I is 0. We want to know the V sub F when it hits the ground down here. So again, we're still using kinematics here in this unit as well. So what do we do first step in kinematics? We're going to go ahead and write down all of our variables. We have a D, an A, a T, a VI, and a VF. My distance is 25 meters. A is negative 9.81. The T was never given. The VI is 0. My V sub F is my question mark. Remember, we go ahead and use our flow chart. Was distance ever used? Yes. Was T ever used? No. So in this case, then, we're going to go ahead and use A equals VF squared minus VI squared over 2 times D is my equation. I'm going to plug it into the triangle so I can rearrange it. But before I do it, is this a good equation? Remember, my flow chart is just a flow chart. It's not 100% guarantee you. Let's see. Do I have the A? Yes. The VF? Question mark. VI? Yes. The 2? Yes. And the distance. Looks like this is a good equation. Remember, we did this one already in class. So rearrange it with the triangle, and it's going to come out looking like VF squared minus VI squared equals A times 2 times D. VF squared minus 0 squared equals 2 times negative 9.81 times 25. I can cancel out this 0, this subtract 0. I can multiply those numbers. VF squared equals, when I multiply all of those numbers, I end up with the negative 490. We did this in class. And we also talked about this. This is a square. The opposite of a square is a square root. So I know you know that. You're going to have to square root this. But remember, there's a negative value here. You cannot put a negative number and square root it into your calculator. What does that negative mean? Direction only. So what am I going to do? I'm going to ignore it for right now. I'm going to still go ahead and put 490.5 into my calculator without the negative. Find out that the V sub F comes out to 22.15 meters per second. Am I done? No, I'm not. This is a negative number, so I've got to put the negative back in. So we're going to, on this unit, get to some math where we know the value of that negative is not going to be numerical. And so we can just go ahead and just throw it out if need be. Okay? Let's go ahead and let's go to the next one. Well, the next question here says, well, what about how much time is it going to take? If there's a person who's walking by the sidewalk, okay, below, how much time do they have to move out of the way before the flower pot is going to hit the ground and possibly hit them? Well, again, I would do the same thing. I have my variables, the D, 25, the A, negative 9.81, the T is my question mark, the VI is 0, the V sub F is negative 22.15. So here's all my variables. Let's go ahead and use the flow chart. Was distance ever discussed? Now at this moment, I can use any equation. If I do, then I'm going to get to the harder equations. But if I say no, then I can say, okay, well, let's go ahead and use A equals VF minus VI over T. Would this equation do it? Do I have the A? Yes. VF? Yes. The VI? Yes. The T? No. I can go ahead and solve this, which I'm going to do that. And I'm going to rearrange it with T equals VF minus VI over A. I'm going to expect you now, since I've already set this up, solve this. And I'm going to just continue for the rest of the school year to highlight the area that I know for sure I did not do in class, but yet I know that you can do on your own. Did you go back and finish up the notes? So again, you'll lose points if you don't fill this in and finish this off. Let's go ahead and go back with our notes over here. We talked about this section as well in class already. Magnitude and direction is vectors. And one direction, or vectors at all, just in general, have magnitude and direction. That is true. Scalars just have magnitude, which means amount or how much. They have no direction. Okay? So determine if the following here are vectors or scalars. Well, this is a scalar and this one's a vector. Okay? No direction, direction. And vectors can be represented. We've already talked about this with arrows. We call them vector arrows. Now, the direction of the arrows indicates the actual direction of the vector. The length of the arrows indicates the magnitude of the vectors. Longer arrows have greater magnitudes. So let's go ahead and draw the following vectors here. What would the vectors look like? If this one's going west 200 meters per second, well, I'm going to go ahead and determine my vector of 200. So for me, here's my 200. But if I'm going to draw another vector arrow that's 100 meters per second, then I better draw it half the size of this. Because remember, the size of the arrow indicates the size of the magnitude. So about here, 100 meters per second. What about northeast, 50? Now my 50 better be half of this 100 arrow. Northwest. Meters per second. Okay? Let's continue. We know that vectors that are in the same direction are added together. Vectors that are in opposite direction are subtracted. Find the resultant vectors in the diagram to the right. The word resultant means the overall answer. Okay? Overall, where is it going to end up at? So let's look at this one. Same to the right. We're going to add them. So we're going to end up with 10. Now I need to combine those actual lengths. I'm not expecting you to go grab your ruler and measure this one and measure this one, but I need to be able to eyeball and say, oh, okay, I don't want an arrow that size, because these two arrow sizes need to be added together, literally, like if you were to add them, 1 centimeter and 1 centimeter. I mean, I'm not going to sit here and measure with the ruler if you did, but it should be about 2 centimeters in length. 10. Is there any SI units? No, so I cannot. But if they gave me SI units, I better add those units. Those are in opposite direction. Positive 5, negative 5. What happens? They cancel out to 0. No arrow. There's no direction. 5 plus 10 better equal a 15. The next one, 5 plus 10. In the opposite direction, it's going to equal a 5. 10 plus the 15, but in our opposite directions, are going to end up with a 10. And then a 10 plus 15 is going to end up with a 5. And we talked about this already in class on this side. It says here, what would the direction of the resultant vector for the picture over here to the left? If I'm going to, that's vector arrow A, and that's B. So if I start here, I go over here first, then I turn and go this way. My resultant vector is going to be in this direction. Right? So an example, if you're here at your house, then you've got to go to, I don't know, the store, then you got to go over to the school. Okay, you can't just take a straight shot. That would be the resultant. Overall, this is the direction you ended up going. Okay, that would be nice. But sometimes there's like, trees and grass and stuff that you can't do that, and you have to go other directions. But when it comes to resultant vectors, they're looking for one vector arrow only, and it's going to be straight. Okay, it's not going to be two arrows, and it's not going to be curvy or bending. One straight arrow. Let's go ahead and turn the page. Again, we talked about this already as well in class. I just want us to talk about it first in class before I posted the video for you. So we talked about the person who was visiting, and they wanted to come over here to the pyramids, and here they are. And they're going to actually walk and go up the pyramid and climb the pyramid. Like, who wouldn't if you're there? That's so awesome. We also saw that the height of this pyramid was 138.8. The width of this pyramid is 230.4. We talked about this. They are going to try to trick you. Okay? First thing is, I can see that a right angle was formed, and so this is going to be Pythagorean. If I have two sides of the leg, I'm looking for the other side. We're going to Pythagorean this. We remember a squared plus b squared equals c squared. A is the length of one leg. B is the length of the other leg. And C is my length of hypotenuse. Right? And it's also, the longest leg. It's going to be, look at this, opposite right here to that right angle. Okay? So the opposite side of it. All right, not a problem. Now, we had a problem here because some of us knew and some of us did not know that this right angle, we're only looking and using this part of the triangle. We're not using this full length. And because of that, this number right here needs to be divided by 2. Okay, that has to happen. Divided by 2. So it comes out to 115.2. That's the number I'm going to use. So it says over here, well, now let's go ahead and actually use their equation to find the distance that they're going to climb. So here's our picture that we drew out. A squared plus b squared equals c squared. And I'm looking for c right here, leg C. And it doesn't matter if I use this number or this number for leg A. But remember, this has to be cut in half, divided by 2. I'm going to go ahead and just do 138.8 square plus 115.2 square equals c square. I'm going to go ahead, do the math here. I ended up with 19265.44 plus 13271.04 equals c square. We added those two numbers together, and I got 32,536.48. We are looking for c square, so we're going to do the opposite of squaring it, and we're going to square root this side and square root that side. C equals blank meters. Okay? C equals blank meters. Again, I'm going to go ahead and highlight this because I'm leaving this part right here for you to do. I think it's appropriate if I set you up and I explain it all that you can go and actually push the numbers into the calculator. Objects traveling at an angle can also use Pythagorean theorem to solve for other unknown vectors on the x and the y axis. For an example, here's our airplane, and I know that the airplane is traveling this direction. Okay, and in physics, we like to put everything into a graph X and Y axis form. It really helps us out. And so if I come over here and I create this, now I can see that here is my vector arrow of my airplane. I can go ahead and I can make this leg over here, and look at this. We have a right triangle. Now if I know this vector arrow, then I can find the other two vectors if I needed to. Okay, now before I do that, I have to have two things, two pieces of the pie. So we're going to get to that when we get to the next page, so we can do this kind of math. Let's continue to practice over here. It says here that a truck driver attempting to deliver some furniture travels 8 kilometers east, turns around and travels 3 kilometers west, then travels 12 kilometers east to his destination. What would his path look like in a drawing? Well, they're trying to guide you to hint, hint. You're going to probably need to draw this to help you out. Drawings are great in physics. So let's go ahead and start off here. He traveled first east 8 kilometers, a vector arrow of 8 kilometers. Then he stopped and he traveled 3 kilometers west. Then he stopped again and he travels 12 kilometers east. What would his path look like? His path would look like that. All right. Next question is, what distance has the driver traveled? Remember, when you see the word distance, you're going to think add. You're going to add them all together. So let's go ahead and do that. 8 plus 3 plus 12. All right. That's going to be 23 kilometers. Here's the math for that one. Well, letter C says, well, what is the driver's total displacement? Draw arrows. Okay, well, I can do that. I've got 8 and 3 and a 12. First thing, if it was me, I would try to narrow it down to 2 arrows. And I can go ahead and do that. This arrow and this arrow are both pointing to that direction, to east. So I can go ahead and I can add them. 8 plus 12 equals 20. But I see that there's 3 in the opposite direction. So I've got 20 in this direction. I got 3 in this direction. Now I see that I'm down to 2 arrows, which helps me out. And I can see that I'm going to have to subtract them. So now that I have 20, I'm going to subtract that. And you end up with 17 kilometers. And if they want me to draw an arrow, I can draw the arrow this direction. Oh, sorry. That direction. How do I know? Well, come over here. Look at the 20 and look at the 3. Which arrow's bigger? The 20. And it's going in that direction. That's going to be the winner. That's the result. The winner over here. All right, let's keep going. While following the directions on a treasure map, a pirate walks 45 meters north, then turns and walks east 7.5. Well, again, the best thing to do is to go ahead and do drawings. 45 meters north, turns and walks east 7.5 meters. What single straight line displacement, or what would be the resultant that the pirate could have taken to reach his treasure? He could have taken this one right here. That can be his resultant arrow. Draw it, then answer it. Well, in this case, his resultant arrow would be this one. What is that leg? I see that I'm going to use some Pythagorean. A squared plus B squared equals C squared. Or 45 squared plus 7.5 squared equals C squared. Okay? Again, I know you can do this, so I'm going to pause and I'm going to leave it there. I'm going to highlight this area because I know that this is another area when I'm grading your notes I'm going to look at to see that did you finish and find what C is. Okay? Not C squared, but C. Let's keep going. Emily passes a soccer ball 6 meters directly across the field to Kara, who then kicks the ball 14.5 meters directly down the field. Okay? What is the total displacement as it travels between Emily all the way to all three girls? She passes it directly across the field. Did they tell me that across the field was right or left? You have to start using your clues in the word problem. Did they tell me which direction? I mean, which way is it's across? Am I going right or left? +6. I'm moving this direction. Then they did tell me down field 14.5. Yes, 14.5 is a positive number, but they gave me the direction of down. So 14.5. What is the total displacement? The total displacement, or the resultant, is going to be this direction right here. What is it? Well, I can Pythagorean this. A squared plus B squared equals C squared. Or 6 squared plus 14.5 squared equals C squared. And I know you can finish this part up and you can practice and finish this up yourself. So I'm going to go ahead and highlight this area also. Now the next page, I would not do this next page. I stopped right here. I was like, nope, no more. Okay. On the next page, I would prefer it if you could, if you get the chance to watch the video first before you actually are in class. I just think it would be a little bit more helpful that way. Okay. Now, before I go any further, again, I do not know your math skills. I don't know your previous math teacher. I don't know if they were an amazing geometry teacher or if they were not. Maybe because something was going on. Maybe they had to miss some schools, or maybe you were ill and you missed school that day. I don't know. But let's go ahead and we're starting off at the basics. So some of you who are going to get mad and frustrated at me, like, I already know that. I know you might, but that doesn't mean that everyone knows. And so for one way for me personally to know that everybody's on the same page is to start from the beginning. So we are starting from the beginning on right angles, 90-degree right angles for triangles.